welcome to the group exhibit Hydrogen Fuel Cells and Batteries at the Hannover Fair 2017. We are here at the Technical Forum and my name is Muriel Buarcas. Today is our last day at the Technical Forum having presentations, and I'm very much looking forward to the upcoming presentations. I would also like to give a warm welcome to our guests watching the presentations today online through our live streaming. Please have a seat, join us for some morning coffee, some fresh drinks. I'm very happy to have you here. The first presentation of today will be regarding the topic test procedures, standardization for the industrialization of solid oxide cells. Please welcome with me on stage Center Manager of DTU, Dr. Ravn Nielsen, and she's representing today SOCTESQA Q&A. Thank you very much.
Thanks a lot. Good morning, ladies and gentlemen, and the audience online. I'm here today to tell you about results and outcome of an EU research project named SOCTESQA, working on standardization of test procedures for solid oxide fuel cells and electrolyzer cells. The project has been carried out by 7 different research partners skilled in testing solid oxide cells, some partners very skilled and experienced. The project has received funding from FCH Joint Undertaking and also from the Danish EUDP program. I myself represent FCH Test Center at DTU Energy at the Technical University of Denmark. So shortly, we offer, as you will understand, testing of cells and stacks. We offer training of engineers and technicians. We offer consultancy for organizations and companies. And we participate a lot in various project works. But and we have a booth on our own here at the fair, E61. But now to the project, SOCTESQA. The full title is Solid Oxide Cell and Stacks Testing, Safety and Quality Assurance. The project is and has developed uniform industry-wide test procedures, experimentally validated these procedures, and identified the most relevant parameters to control in testing of solid oxide cells. And also, as you could see if you were here yesterday, talk of Stephen McPhail, we have already made some work to implement these new standards, these new procedures in international standards. So this work is already ongoing. The main message of my presentation will actually be come and visit the project booth. It's just in front of the public forum. And also go to the webpage of the project, SOCTESQA.eu, where you will find the test procedures that has been developed. And within the next 6 weeks, the project will finalize, and all modules and programs relevant for industry and test institutes will be available there. Solid oxide cells are high-temperature ceramic cells. When they're used as fuel cells, they produce electricity, but they can also, the same cells, stacks, or units, can be worked in electrolyzer modes, turning power into gas. Some of the applications for SOC is stationary SOFC applications like micro CHP, that's combined heat and power for residential use. That is one of the early applications, as well as mobile application auxiliary power units for trucks. That was for the fuel cell mode. For the electrolysis mode, power to gas, we have We can have a situation with surplus of power from wind or from solar panels. We can transfer this electricity into hydrogen. The hydrogen can be stored in a storage tank. It can be fed into the natural gas grid. It can be used for refilling stations. It can be used for electricity generation again. It can be used for heat. And if you store the hydrogen, you can later feed it back in the fuel cell. And the same unit can be used as an electrolyzer and a fuel cell. You can feed it back and produce electricity to the grid. And that's a way to balance the grid. And we use that explanation as power to gas to power. That's the term we are using, reversible SOC. Here's an example from real life on a wind profile, wind energy produced in a Danish island. And it goes up and down. These are, over the scale here is days. So when the blue is how much energy is produced. The red curve is actually the energy consumption of the residents in this island. And sometimes there's a surplus of energy, sometimes there are too little. And then we can use it, the hydrogen, feed that back into a fuel cell, and then supply and provide further electricity. And that's, the reversible operation. In the beginning of the project, 3 years back, we made a literature overview of the existing procedures or standards within testing of solid oxide cells. And it's actually a rather good overview. You have access to the document on the website. We were listing relevant modes or part programs you could use when characterizing these cells. And the document lists how many already existing documents were there on these specific parts and methods for SOC. And we clearly saw that actually for SOEC there was not one single document there. And for a number of the other methods, like electrochemical impedance spectroscopy, there was also no standards available. And for many of the others, there were of different details. And what we have been doing is also making guidance and experimentally validated the procedures that we have developed. Here you will see actually a picture of a small stack set up in the test station. And it's rather complex. Here you have a mechanical load. You measure electrical content, a current, air in that can have a temperature, a pressure, a purity. Same, you have fuel gas in, composition, temperature, pressure. Again, what is the purity? It can also be water vapor. You can measure and control air out, fuel out, voltages of each single cell and of the entire stack. Temperature in the furnace, various places of the stack. It's rather complex. And it's complex to control all these and keep them stable in the way you want. And to compare from one laboratory or one test station to another is not trivial. So this sketch actually says much of the same, that when measuring either cells or stacks, there are so many subsystems to control. And this complexity of testing makes it even more important to have standards that also explains to you how to measure, how to control, how to make such a test in a most reliable way. We control test input and want reliable test output, the results of the test. That's the whole idea. And we have made a base document where we define all these parameters of input and output. And that's actually the base for the whole test procedures that we provide here. So the base document is, besides the test modules that describe how you do it, or what parameters, what numbers you should go to be able to compare with other results in literature and in projects. Then we have this base document, full description of input and output, defined and where you measure, how you measure, the derived quantities, so how do you do your calculations based on your direct measurements, because often the direct measurements are of no interest. Then we give a number of recommendations of how to proceed with the experimental work. So if you're a newcomer into testing, this document will be of high value for you. And then, as I concluded by the literature search, our documents fulfill the gap where there was no existing standards available. The approach has been 4 test campaigns between the 7 partners, and around 45 small stacks have been tested throughout these 3 years to validate and to pinpoint where are the challenges and where, how should we do, where to be careful to have reliable results. So there was a first validation round of test stations. Can we at all fit the unit into our test bench? Can we connect? Can we measure or follow a simple program that we set up? When we have that in place, then we are describing test modules, and a module is a small piece of a program that you can place whenever. It can be an IV curve characterization, and you can place that different times in your own test program. That's what we call a module, so a piece of a program. So these modules have been defined, detailed, described, and then we have validate them experimentally across a number of different partners, different test laboratories. There has been improvement and programs have been made, and all have been finally validated, and the programs and modules will now be available for everyone to use. We have been focusing on repeatability and reproducibility, both within one partner and across partners. And the sensitivity analysis, if you change, well, when we see differences between partners, what can explain it? Is it that even though you aim for 750 degrees on your top plate of your small stack, maybe it's 760 instead? Will that explain the differences we see in performance? And also things like gas quality, air quality. You would not dream of the differences between laboratories. So these differences can explain differences we see in performance. Yeah, and then calculations of the quantities of interest. So by the end, we have these test modules, these pieces of programs that we call generic test modules, like test module 05, electrochemical impedance spectroscopy, guidance how to do it, parameters, definitions, specifications. So this is a standard you can follow, and you can later compare in literature and across laboratories. Temperature sensitivity, operation under constant current, all these test modules that you will know is important when you characterize your system. And furthermore, we have combined these test modules into 4 application-specific relevant programs. So if you want to test if your product as a manufacturer, if your product is suitable for a power-to-gas application, you can follow this test program and compare with others. Again, come and visit the project booth. It's just in front of the public forum. And also go to the web page and find the modules. This is just a snapshot of some measurements we have been doing. We are measuring IV curves. We are measuring impedance, electrochemical impedance spectroscopy. We have been calculating then from these measurements area-specific resistance from 2 different methods, from the impedance and from the IV, and shown that there are actually rather good agreement between these 2 methods, which is very nice that we can confirm that both methods can be used for deriving this parameter. And we have also performed quite some long-term testing under constant current. So this is 1,000 hours, 2 different laboratories, and we measure the voltage versus time, so the degradation in performance. You can find and learn much more about these results on the homepage and in publications and presentations that will be going on over the next 3 months, and conferences also. Here's an example on the first test program for stationary application, meant to reflect the micro-CHP application. And all these boxes represent 1 test module. So we have startup module followed by the first IV curve, impedance, and then we go to constant operation. You measure temperature sensitivity, and by the end you shut down. So this is an example of how we have defined a program based on the modules, but you are welcome to take these modules into your own applications or your own needs and combine, see how, and you can still refer to that you are fulfilling or you're following the test procedures made here. I showed you this before. This is a power to gas to power application. So this was what it looked like in real life. And we have then defined test program 4. That would transform into a simplified procedure that every laboratory should be able to follow. So the red lines is a characterization, and then all these dynamic is example of wind profile or sketch simplified, and solar profile, and how often we are changing. So this is an example of how to follow our test program for a reversible operation. I can say that already now, these new procedures, modules and programs are being implemented not only in the international standardization, but also in work in our laboratories in EU projects. I'm pretty certain that FCH joint undertaking will ensure that these are further implemented in future projects so that we can compare and test as equal as possible. So these are examples of 4 already ongoing projects who has implemented the modules and programs, this way of testing already. The overall outcome has been a literature review that is available for everyone, 13 specific test modules, 4 application test programs. These have been experimental, validated in 4 testing campaigns. We are contributing to international standardization. We have been through the process of improving, optimizing, and validating test procedures and programs. And as I just mentioned, they are already implemented in project work. By this, I will, for the 3rd time encourage you to visit the project booth just in front of public forum next to the DLR booth. This is a sunny and windy day at DTU where the project team was having a meeting, and logos of the partners involved, and all the information can be found at the project website. Thank you.
Thank you very much, Eva. Are there any questions from the audience? I know it's still early in the morning, waking up everybody, so I will start with the questions. So it's not the first presentation we had this week regarding standards and regulations that need to be implemented, and it's not the first time you are on stage this week. So I was wondering, you're quite involved in different projects. Do you think collaboration is the key to actually get the standards implemented at the end? Do you see a development?
I see it is important that the procedures when developing new standards will take place similar to what we have here. So the partners, organizations used to test, used to use the future standards, must work together, must find a common ground, must interact with industry. We have had an advisory board commenting, informing us of their own conditions and their own testing in laboratories where they're preparing for their applications. So this interaction is important, and then very soon to implement it both in the standardization and in the real use. So,
would you wish that more companies are involved, or do you wish that the European government is putting more regulations in place?
I actually see very high involvement and already by the EU. Things are going on, and also industry has been very kind to take part in this and to make sure, also for their own sake, that these future standards will be relevant to future testing.
Thank you very much for your time and making the start in the last day.
Yeah.
One warm applause for Eva, Ravn, Nielsen.
Thank you.
The next presentation will continue in a few minutes regarding the topic, the case for containerized hydrogen solutions, with John Cornish, President of Engineering, Procurement and Construction. See you in a few minutes. Join us for the upcoming presentations. Have a coffee, have some refreshments, and we continue in 2 minutes. Thank you very much.